So thank you for honoring me with your presence. I know who the diehard music fans are. They're in this room because I'm competing with Stefan Janssen, the organizer of all the DevOxes, doing machine learning. So I realize that you're making a sacrifice to come here to hang out with fellow musicians and music enthusiasts. I appreciate that so much that I want to get a selfie with y'all. So that's the way we talk in. I speak American, right? So here we go. I would like to for you to honor me with a crazy pose, please, because I know you're all crazy. Ready? 1, 2, 3, crazy. Thank you. All right, nice. And let me go ahead and tweet that here. If you're not supposed to be in this session, let me know. Otherwise, I'm going to go ahead and tweet this. There we go. Wonderful, thank you. So this is called Composing Music in the Cloud, and it's about algorithmic music composition. My name is James Weaver. My friends call me Jim. Please do call me Jim. I work for Plvotal. Those are my coordinates. And the hashtag is, of course, DevOx UK. Please tweet, live tweet this session. I'm actually going to go into the technical details after I've given you a primer on this application that I've written called Counterpoint Composer. And so this is called Counterpoint Composer. You can actually get to it from here, counterpointcomposer.com. And so even if you have a tablet or a machine, any kind of notebook, then you could actually follow along and do this with me, because it's just at counterpointcomposer.com. And these slides, by the way, are in the help. So the technical presentation is one deck of slides that I'm going to show you, but first I'm going to show you the getting started slides. And so you no need to take pictures of the slides or anything like that. You can just access them online. So about me, I've written several Java books, starting in '96 with the Inside Java, wrote some EE books and some FX books, and then the most recent one was with a colleague of mine and I, Stephen Chin, writing one on Raspberry Pi with Java. So before I can talk about what this application does and the technical architecture, I need to define a few things. Being music fans, you probably already know this, but I'll go ahead and go through this anyway. So what is counterpoint? This counterpoint is this idea back in the 16th century or so, that began around then, is this idea of writing several melodies that then sound pleasing together. So that they are voices or melodies that then are interdependent harmonically. So when I play 2 or 3 or 4 notes at the same time, they need to be pleasing to the ear. So they're interdependent harmonically, but then independent in rhythm and contour. So each melody line could have a different rhythm, it can have a different contour with the notes rising and falling, the tones rising and falling. And if you wanted a good introduction to what counterpoint is, this gentleman by the name of Nicholas Tollervey wrote a great article on species counterpoint that I'll be talking about today. And that's a great primer on it. So here's an example. It's a little bit small, but you can get the idea of the interdependence. So you have 4 lines of music, and then sometimes notes are playing at the same time. And then, but notice that also the rhythms and contours, the rising and falling of the different notes, are independent of each other. Also, would like you to point out there are different chord markings. So those things like that you see up there, D5 or C major with an E bass, those are chord markings that I'll be talking about in a little bit. So I'm going to go ahead and play an example. Can you turn the... The idea of being interdependent harmonically, but then independent in rhythm and contour, that kind of exemplifies that. So where did counterpoint come from? And specifically this thing called species counterpoint. Well, in the 16th century, this gentleman by the name of Giovanni Palestrina created this counterpoint style called Palestrina counterpoint. And he was best known as a 16th century representative of the Roman school of music composition. And so he influenced composers such as Johann Sebastian Bach. And then in the 1700s, this gentleman with a very awkward last name, Johann Joseph, I think it's pronounced Fux, but so he took Palestrina's techniques and codified them. So he identified the rules that seemed to be, governing Palestrina's style, and he kind of expressed them. As a matter of fact, he expressed them in a book called Gradus ad Parnassum, which then is it's kind of almost a novel in which a student and a teacher are discussing how to create counterpoint, and the teacher is leading the student through these 5 species of counterpoint and how to correctly compose it, and in the process defines about 70-some rules for species counterpoint. Rules such as harmonic intervals, and if you have 2 voices, what is legal and not legal. If you have 3 voices, what sounds good and what doesn't sound good. So in that book, you can pull about 70 some odd rules out of that. So later, people like Bill, I can never pronounce his last name, but he's a computer scientist and musician, in the 1980s took these rules out of Gradus ad Parnassum and created a procedural C program that then, at the command line you could type in a main melody and an initial chord, and then define a couple of other things like the mode and what species of counterpoint you wanted, and then it would generate counterpoint for the other melodies, the other melody lines that you want. And so in, about 6 months ago, then I built on Bill's work and created an application then to take those rules. I ported it to Java, and then made those into a couple of microservices, pushed them in the cloud, using Java and Spring and Cloud Foundry, and so they're just resident in the cloud now, and you can use it anytime. Got some universities that are using it for some of their courses, specifically on counterpoint, and you're welcome to use it anytime. It's free, open source. I'll show you the links to the open source software on GitHub. I just did this presentation in Poland at Geekon, and so a lot of composers were influenced by Johann Joseph Fux. Like, for example, Chopin, who's a Polish composer, was influenced by Fux. In this relationship where, like, for example, Chopin was a student of this person who was a student of this person. And so as bonus material, I'm not doing this presentation at Devox UK, but I did want to expose you to this application. It's called conceptmap.io, and so you can click that sometime. And it's this from a presentation that I do called Navigate All the Knowledge. And so it's another application that lives in the cloud. It's got 20 some odd microservices and an HTML5 front end that you can use. But relevant to this presentation, I wanted to show that Frédéric Chopin has a relationship then with Fuchs through the student of relationship. So these are all relationships between these that are pulled out of this thing called Wikidata, which is a sister project to Wikipedia. So if I look at student of, I can see that Chopin was a student of these folks. So I'm going to do then a shortest path navigation between Chopin and Fuchs, and then it pulls out the people between them. So Frédéric Chopin was a student of Wilhelm, student of this person, etc., to Johann. So I just wanted to show you that application in case you wanted to play with it sometime. If you go into that application, then it's got a presentation on it with its architecture. So back to our original topic. So you're all familiar with Twinkle, Twinkle, Little Star. And what I'm going to do is use that as our main melody for this application. So first of all, I'm going to plug in this instrument that I've been playing with for the last several months. It's called a Linstrument, actually. It's a MIDI controller. It's kind of a fun instrument. It's got 8 rows by 25 keys. It's a three-dimensional controller, MIDI controller. Those familiar with MIDI know that the MIDI standard is 0 to 127 as far as resolution for pressure. And so, it's got 0 to 127 pressure, 0 to 127 on the x-axis, so I can do slides and things like that. Kind of feels like a guitar in that sense. And then 0 to 127 in the y-axis for timbre or tone color. So I'm going to go ahead and plug that in and pull up this thing called Logic Pro. And we'll select flutes here, and I'm going to play Twinkle, Twinkle, Little Star in case you haven't heard it before. So anyway, there's Twinkle, Twinkle, Little Star. Oh, no, thank you. Oh, you're applauding and laughing. That's great because I was prepared. If you didn't, I brought my own applause track and my own laugh track just in case you didn't applaud. But thank you for gratuitously, applauding and laughing. So that is going to be our main melody, Twinkle, Twinkle, Little Star. It's also called a cantus firmus, means main melody, I guess, in Latin. So if you ever miss me,
Hi, this is Jim Weaver,
then you can go ahead and go to the next slide, and I'll talk you through this. But I'm here now, so I'm going to actually use the program to talk you through this. So let me plug my mouse back in and unplug this guy. And we'll go to Counterpoint Composer. Now, all you do here is go to counterpointcomposer.com, and we'll go ahead and I'm going to hit clear to kind of clear everything out. And you notice we have a staff here, and then if I hit keyboard, we have a keyboard, and I'm going to click into the staff, and I'm going to compose two-part. I want two-part counterpoint. So I'm going to give an initial chord that has 2 parts. So the first one is going to be an E, and then the next one will be a C, like for the first chord, and then we'll continue playing Twinkle, Twinkle, Little Star. So notice I have an interval there. So, da, twinkle, twinkle, okay, there we go. So now I'm going to make sure that I have first species on, because we're going to go for the simplest one first. And then, so who can tell me what modes are? Who can tell the audience what modes are? Just as a refresher. Give me a musician. I'm gonna pick on David again. Okay, David, tell me what modes are in 30 seconds or less.
I'm looking at the same scale from 7 points of reference.
Okay.
Major, minor, minor, major, minor, minor, diminished.
Nice, nice. So.
Half diminished. Sorry.
Yeah, I was going to call you out on that later, but yeah, nice. Okay, so 7 points of reference. The diatonic scale has, no, I mean the diatonic. Diatonic has 12 notes, right? What would you call?
That's the chromatic.
Chromatic. Diatonic scale has 7 notes. So if you go to C to C, that's Ionian mode. D to D is Dorian mode, etc. But they all have different feels, different flavors. So I'm going to do the C, the Ionian mode, just for simplicity right now, and then hit compose. And before I play it back, I'm going to go ahead and give it 200 beats per second so that it doesn't sound like a funeral dirge. I'm sorry? Minutes, thank you. I was just checking to make sure you're all awake. Okay. Okay, so you notice the D5 and the G5, those are chord notations. Again, I'll highlight those in a minute. So now if I wanted second species, obviously first species is called note on note. So it's rendered as whole notes, and the other lines in it are whole notes as well. The second species is note, and then like whole notes, and then half notes in the accompaniment, in the other melody. So go ahead and select second species and hit compose. And so this is what the second species, those second of the 5 species that were defined by Fux. Speed it up to 200 beats per hour. And you can start to see some of those rules just kind of playing out, can't you, as far as the idea of not moving too much, or not having awkward movements, or not using, who knows what the devil's chord is, the devil's interval, so tritones, not having tritones and things like that. So now we'll go ahead and do third species. Third species is whole notes and quarter notes, so 4 notes per each whole note. So go ahead and compose that. And the fourth species is this idea where you have whole notes in the cantus firmus, but then you have half notes. But the half notes are kind of tied between measures, and so you get this nice effect of kind of a suspension or a tension, and then a release in the next measure. And so I want you to listen to the kind of the tension at the end of one measure, at the second half of one measure, and the release at the first half of the next measure. So we have fourth species. We will compose. I haven't implemented the ties yet, so you'll hear 2 notes, but just imagine that they're kind of continuous here. So here we go. And then the last species is a combination of all of those. It's called florid counterpoint. Combination of all of those, plus the interject some eighth notes, and so this is an example of that. Okay, so now these next slides then just kind of go through what I just told you in a lot of detail, with sometimes with videos, with links to resources, like for example, each of the types of counterpoints, there's some links to resources in Wikipedia and also in this site called Open Music Theory. So for example, if you wanted to learn how to compose a cantus firmus, you didn't want to rip off Twinkle Twinkle Little Star, but you wanted to actually compose one yourself, then there are some rules for doing that, and you could look that up on composing a cantus firmus. So I just went through these next several slides with you. And then David was kind enough to tell you about the different modes. So I'm going to go ahead and play something using Dorian mode. I'm going to start with D. I'm going to start the cantus firmus with D, end the cantus firmus with D. And so you'll get a feel for what Dorian mode sounds like, as well as how to compose, how to have the application then compose the counter melodies in Dorian mode. So we'll go to Counterpoint Composer. I'll go ahead and clear this out. I'm going to go to First Species and select Dorian mode, and click in the staff, hit the keyboard. The initial chord, I think I'm just going to do a D here. Kind of sounds a little bit minor, like David said. So now I'm going to hit Compose. Oh, I already did compose. I'm going to hit play. Okay, you feel that kind of minor feel. And so I mentioned that there are 70-some rules. And so in the application, I created a control panel to be able to switch on and off all of those rules, and that way you can kind of experiment with what the effect would be if we disregarded a particular rule. For example, one of the rules, I'll go ahead and pull up Counterpoint Composer. One of those rules is it's not a critical rule. We have the critical rules first here. It's not a high importance rule, but it is of medium importance, where we avoid unisons in two-part counterpoint. So a unison is where we're playing the exact same note with the same frequency at the same time. So with two-part counterpoint, you only have two notes going on at the same time. So if you played those in unison, it would no longer be very interesting. So we'll go ahead and switch that rule off, where we avoid unisons and two-part counterpoint. Notice that we don't have any unisons here, but also do notice, please, that we have a bass clef and a treble clef. And so this D here would be represented in the bass clef up here. And in fact, when I hit Compose, we see that it actually has allowed a unison to slip in because we switched that rule off. So I'm going to go ahead and play that, and then you'll be able to hear that unison at the end. you also notice that much of the second part changed, because if you change one rule, then the calculations and the melodic rules have an effect, kind of a cascading effect, and so much of the entire bass melody too changed a lot. So that's how we change the rules, and those are the effects. And so now we'll go into the technical aspects. So I'm going to actually go to the application. Here's the technical aspects. And the high-level architecture is a one-page HTML5 application, and then it's got two microservices. One is called Counterpoint Service, and the other one is called Chord Analyzer Service. And those are both living in Plvotal Web Services. It's a kind of a subscription-based cloud platform that hosts Cloud Foundry, and they just kind of live there all the time. Different number of you can scale up and down those instances. If I got more demand, let's say for more users were using it, I could scale up Counterpoint Service independently of Chord Analyzer Service, because maybe that isn't used as much, and so I could horizontally scale those independently. Also, we're using this NoteFlight embedded client. At noteflight.com, there's a really great music notation software that a lot of students use as well as musicians. And so they have an API in which you can embed into JavaScript their API or their client, which contains a musical staff as well as a keyboard, just like I showed you. And so as in the application, I'm interacting with those things, then the APIs are being called to tell it, to find out what notes that I've played, as well as then to be able to load what has been composed in the cloud into it using this standard called Music XML. And so it's a very simple architecture, but it gets the job done. So the source code is in GitHub, and the Counterpoint service, which actually composes the counterpoint, is here. And the Chord Analyzer service, which takes multiple notes that are being played at the same time and analyzes it and tells you what chord's being played, that's in the cloud here, or that's in GitHub here and running in the cloud. So the way that these things are interacting then is when I entered the cantus firmus and entered the initial chord, which indicated how many parts of counterpoint I want, and then also indicated mode and what species. That information then is sent via an HTTP REST call, and we're posting then that information in JSON, such as the main melody, and I'm expressing that in MIDI note values, and then the initial notes for the parts, as well as the other two pieces of information, to Counterpoint service, to an endpoint called /counterpoint. And then it returns, given all that information, it returns this music XML that expresses all of the parts, all of the note values, everything that we need then, and then we load it into that NoteFlight client, and it renders it. And then, but before we actually have it render it, in the cloud, when this is computed, like we find out that there's more than one note being played at the same time, we then make another call to the Chord Analyzer endpoint, giving it the notes that are being played at the same time. And then the Chord Analyzer service, in which we use, it's the endpoint analyze, and then we use the notes. We give it notes that are expressed as, the name of the note, G or whatever, and then the octave that it's in. And then it returns a JSON stream that has the root of the note, the chord type, the base note, everything that we need to then be able to render it on the musical staff. So any questions on that, or actually anything I've covered so far? Yes? Okay, so the question that my colleague asked was, why did I use XML rather than JSON? So I prefer JSON. Everybody prefers JSON, right? But Music XML is kind of a standard that's been around a while, and so NoteFlight Client doesn't have a JSON equivalent for loading, and so they require Music XML, and so I had it. The nice thing is that the framework I'm using is flexible enough to be able to just say, okay, I want XML instead of JSON, and so it just renders that. I said it again? It's a Spring framework. Spring, yes. So now let's look at the resource controller for the Chord analyzer. So we have the analyze endpoint. We're passing it notes, the parameter notes, and some code behind that. Since we're at a developer conference here, I have to show you some code. So we have this class called Chord Analyzer Controller, and we've got this other class called Music Chord. The Music Chord is a POJO that's going to represent the chord that we're sending. And then we have this thing called the endpoint analyze, and so where is it? Request mapping maps the endpoint analyze to this method, identify chord by notes, and then the request param annotation then indicates that the parameter that we're passing in is going to be in this notes parameter. And then we do something with it, and then we return from Chord Analyzer Controller this music chord. And so because this package called Jackson2 is on the class path, it just automatically converts the music chord instance to JSON. And then we can also indicate that we wanted XML as well if we wanted. And so the way that we represent music chord is by using POJOs. So that's just a plain old Java object. And that gets serialized and deserialized over the wire very easily. And then to make it executable, we use this annotation called Spring Boot Application. And we have this class called Chord Analyzer Service Application. It's got a main, and when we just say Spring Application Run, passing in the name of the application. And so if you wanted to know more about that or how to quickly stand up a REST service, you could just go to this link, Building a RESTful Service. As far as application and building and deploying, it's really simple. I use Maven, and so just Maven clean install, and it builds it, creates a jar file, and then to push it into the cloud, we just say CF, which is Cloud Foundry push, and then we give it the name of the jar, and then what we want that service to be named when it's in the cloud. And that's literally all we have to do. So it's kind of an easy button. And so I'll just show you these real quick here. This is the Plvotal Web Service console that then you can monitor your running applications. So there's Chord Analyzer service and Counterpoint service. And how many instances? I've just got one instance of each, but I could scale those up and tell Cloud Foundry, okay, I want 5 instances to run all the time of Counterpoint service. And if one dies or an availability zone underneath it, maybe in AWS, Amazon Web Services availability zone disappears, then an instance dies or they all die, then Cloud Foundry will make sure that they're replaced with running instances. So it tries to honor that. And then to actually create applications from scratch, you just go to start.spring.io and give it things like, in this case, we wanted to stand up REST services quickly, so you would select dependencies for REST services. So now I want to show you the Chord Analyzer client in action. Remember this diagram? We had, in the cloud, we have Counterpoint service, and then we have Chord Analyzer service, and in the application, Counterpoint service calls Chord Analyzer service when it needs to figure out what these number of notes are when they're played simultaneously. So I'd like to test that independently, or use it independently from a client, an HTTP or HTML5 client. And so there's this application, Chord Analyzer Service, that's a client that I've written so that you can do that. So I'm going to go ahead and so it says no MIDI devices present. So I'm going to unplug the mouse and plug this guy back in. And so it should satisfy it. And I'll pull up Logic here to make sure that I've got a piano. So now what's going on is so there's this thing called Web MIDI. There's a Web MIDI API, and it was it's implemented by Chrome. I wish it were implemented by more browsers, but it's only implemented by Chrome now. But it's supposed to be this this open standard. It is an open standard, but so far it's only natively implemented by Chrome. So I'm going to use Chrome and connect it to this controller, this MIDI controller. So as I play notes on this, it'll be reported to Chrome, and then I'm using JavaScript then to capture those events that are coming in, and then we're going to take those events as I recognize notes or one or more notes. When I see more than one note being played at the same time, I'm going to make a request to the analyze endpoint, like we did from the cloud. I'm going to make those from the client. And then it's going to take that request, analyze the chord. And by the way, I didn't mention this, but there's a colleague named David Cole that makes an application called JFugue that expanded JFugue at my request to do chord analysis, and so we worked together on how to do that. So it's going to it uses that library, but it's running in the cloud. It's going to return then that serialized music chord, and then we're going to display it on the second line chord. So as I'm playing, it'll be interactively doing that. So Chord Analyzer client. And so while I'm doing that, I'm going to hopefully not butcher too badly Prelude in C by Bach. Let's see here. Here we go. But it's not doing any chords here. Sorry? I'm in Safari. Right. Okay. Maybe I'll just I'll refresh it. There we go. So that's my presentation. Thank you very much for your attention. So we still have, thank you very much. We still have 9 minutes left, so if you do have any questions, please ask them or come up to the podium. Yes. Can you speak up on your questions, by the way? I barely hear you when you ask. That's all right.
I was just wondering with the Counterpoint application, does it, like, without changing the configuration, can you get loads of different counterpoints, musical counterpoints, or do you have to change the configuration just to change?
Okay, so the question is, if I would hit generate counterpoint more than once, maybe, would it tend to create a different counterpoint or the same one. And so, so in the case where, for example, if I go here to Counterpoint Composer, in the more advanced species, like fourth species or fifth species, then you'll tend to get a different ones each time. Like especially with fifth species, because it does randomly, it throws notes out there randomly, right? And then those rules then would throw out anything that doesn't conform, and it checks, it knows the whole cantus firmus at the same time, and it knows the initial chord at the same time, so it calculates everything at the same time. For example, if I wanted fifth species and I hit compose, then we see this. But if I hit compose again, because it's complex enough, then it's throwing out way different notes, and those rules would tend to then make it so that it's not always going to come up with the same result. But in the very simple ones, like note on note, it tends to be the same every time. Right. So yeah, that's a good question. Other questions? Anybody? Yes.
Is there like a sort of stupid question?
No. There are no stupid questions. There are only stupid answers. So I'll give you a stupid answer. Okay.
Is there like something like a musical Turing test where generated music is no longer distinguishable from composed music by people?
Wow, that's a good one. So that's a good one. Yes. So I would just have a stupid answer because I don't know, but I'll bet my colleague David Blevins does.
I'm not a robot, so I don't know if it sounds good.
Yes, right. Yes. I don't know of any musical Turing test. That's an awesome question, and something that, this is open source, so, you and I should collaborate on it. Do a pull request, and let's collaborate. Other questions? Awesome. Thank you so much for coming. Bye-bye.